In this video, I'm going to talk about how to calculate parallel resistances in a circuit. But to give the reason why we might want to do that, I'm going to first take a look at a simple circuit with just one resistor. So I'm going to take a look at a circuit with a single 10 ohm resistor with a 10 volt voltage source. So from our previous video, we know that the current in the circuit, I, is equal to V over R. So it would be 10 volts divided by 10 ohms. So that's 1 amp of current. So we're going to ask that battery to be able to give us 1 amp of current. Now, what if I have a battery, the same battery, 10 volt, but I hook up other resistors, which are basically other electrical devices, very similar to a 6-prong outlet. So there would be 6 of these. So I'm going to put a 10 ohm resistor here, a second one with 15 ohms, and then a 20 ohm resistor, all in parallel. And this is the same 10 volt source. The goal of this is to figure out what these three are equivalent to. Basically, what one single resistor does it really look like? I can replace it a resistor of so many ohms. I want to figure out what that number is. So the question is to find the R total of the parallel resistor. So there's an equation for this. It says 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and if you had more resistors, you just continue. So for our equation here, we have, or for our variables, we have R total we're trying to find. We don't know that. R1 is 10 ohms. R2 is 15 ohms. And R3 is 20 ohms. So to solve this, we just use the equation. So I'm going to take 1 over R total, which is what we don't know, equals R total, 1 over 10 plus 1 over 15 plus 1 over 20. So I'm going to do the math and figure out what number that is right there. So if I take 1/10 and take 1/15 and take 1/20, you should get 0.2167. That's 1 over R total. So we have to invert that or cross multiply. So R total is equal to, if you invert that, 4.16 ohms, which is a lot less than the 10 before. So this is, to complete our comparison, 4.16 ohms. The current in that circuit would be 10 divided by 4.16, which I'm calculating to be about 2.4 amps of current. So we're requiring this battery to give us twice as much current. So it has to be a heavy-duty battery or something like that. This is amperes. Twice as much current, more than twice as much current than before. That makes sense because if I had a single resistor here of 10 ohms, a certain current would flow in it. But if I open up different pathways, even though there are more resistances, like extra lanes in a freeway, then more current can flow. So this is how you calculate parallel resistances with the equation. And the reason why you might want to do that is to figure out how much current a circuit will now draw by the addition of other electrical devices.